This recording is protected by copyright. No part may be reproduced without the prior permission of the University of South Australia.
Okay, so week 6, how time flies. So a couple of reminders for you for this week. Quiz 2 is to be completed this week. It's been open all week. You have until 11 p.m. Sunday to complete the quiz. And your individual assignment is also due this week. Okay, it's due, when is it due? Sunday, 11, and what happens if you hand it up late? 0, unless you have extenuating circumstances or if you've submitted an extension request to me, to which I will respond on that extension request, but you've got to give me appropriate notice. So the link to the quiz is under assessment material. You can also access the assignment and the quizzes via the assessment tab on the course website. So under continuous assessment, I have the quizzes here. The specs and the rubric for the actual individual assignment, which is due on Sunday, again are available here. If you have any specific questions about the assignment, please post them on the Q&A forum. Sorry? Which one? It's, yeah, A1 is continuous, A2 is the individual. Yeah, no, the group one. That's a while away. Does anyone have any questions at this point in time of me regarding the assignment which is due on Sunday? Yes? So, is that your question that you posted on the course website on the assignment? Oh, someone else has posted it, but I haven't responded yet. So you've got to look at it from the perspective of the stakeholders that are mentioned, but there may also be external stakeholders that are not mentioned, which is why I suggested, so someone's posted that question, but I haven't responded yet. You've got to look at it in terms of that diagram that I suggested you look at, and with the grid, to give you a perspective of who the stakeholders might be. Because in a scenario, you're not always given a list of who the stakeholders are, so you have to look a little bit deeper and a little bit further, which is why I suggested using that technique and those strategies in question 1 to enable you to identify extra stakeholders that might not be listed within the scenario.
What about, like, in question 2, sometimes, like, maybe some of the stakeholders are not going to be, like, they're not going to be, like, interested in the system?
Well, if the stakeholders are not interested in the system, then they're not really a stakeholder. A stakeholder has some sort of interest in the system. So,
no, but they're a stakeholder. Like, they're interested in the school, but they're not interested in, like, the system. They might not be interested.
well, there's got to be some sort of aspect of the system which belongs to the school that they're interested in, because they might be at the executive level, for example. They might have an interest. Their perspective might be at a higher level in relation to that system in terms of interaction with alumni or fund. It could be from a fundraising perspective.
What about, like, for example, external executive? What would they do with this?
Well, have a look at the examples. It depends on how they're external and how they're executive. There might not necessarily be, which is another thing, stakeholders in each of those 4 categories. Okay, so just because you've got the grid there, it doesn't mean you have to try and find stakeholders in each of those 4 categories. It's more of a thinking, a brainstorming. It's a mechanism for how to come up with the external, or any stakeholder, but you may not necessarily have stakeholders in every category.
So it's important for us to include only those which can be implemented through the system, or the one?
Well, which have some sort of interest in the system. If they have an interest in the system, interest in the system doesn't necessarily mean that they're using the system. So their interest could be from the perspective of the system belongs to the school and they have an interest in the school. Okay, or or for example, an external stakeholder might have an interest from the Catholic education, like for example, if we're looking at our schools, that might be external that has an interest because they have an interest in the Catholic education system and how they raise funds or something. So it could be from a wider perspective or a political perspective or a government perspective as to what their system is in terms of why they actually have an interest in this system. But it's not necessarily how the system operates, it's maybe the purpose or the function of the system, so from a different perspective. Okay, does that help you a little bit? Okay, so I will address that question, I'll answer again, that's on the course website, on the forum. Does anyone have any other questions at this point in time? Again, I'm happy for you to post questions, and those of you that have, that's great, and I will address them as I receive them in my inbox in due course. So yes, it is due 10th of April, 11 p.m, with 15%, and the details are there. So just a reminder as well that we do have a 2-week teaching break. Okay, so you're more than welcome to come next week and the week after, but I won't be here. So yes, 2-week teaching break. Study period commences, i.e. week 7, after the 2-week teaching break. I do plan on releasing, hopefully you're all in your groups by now, either through myself placing you in groups or through May placing you in groups. Those of you that aren't in groups will be placed in a group by default from either May and or myself if you haven't attended classes during the last couple of weeks. Over the break, it's my aim to post the details of the groups on the course website, as well as post the details of the assignment. The assignment is due in week 11, so you've got quite a number of weeks after the break even to start thinking about the assignment. But my goal is to have the group sorted and at least the specs up so you can start thinking about it, and perhaps start contacting your group members, start assigning who's going to do what, whether you're all going to do the whole thing, whether you're going to do bits and pieces, and go from there. Okay, so stay tuned on the website. If I post anything, I'll post them on the news forum or the discussion forum. I may even send you an email, so just stay tuned for what's happening with the groups and the up-and-coming assignment. With your individual assignment that's due on Sunday, allow a 10 to 15 day turnaround for marking. And marking will be provided via an online rubric similar to the one that I've posted on the course website, and I believe you will receive a notification when the results are posted out to you. So either during the break or probably within the first week back, expect some results for that assignment. Okay, so this week we're looking at domain modelling, looking at things in the problem domain, looking at another type of diagram. So we've looked at a couple of diagrams so far, the activity diagram, the use case diagram. Today we're going to have a look at the entity relationship diagram. So who here is doing databases? Okay, have you come across entity relationship diagrams in databases with Doug? So you all should be familiar with what an entity relationship diagram does and the purpose of an entity relationship diagram. Have you looked at, in databases at all, have you looked at domain class diagrams at all? Yes, no, some of you may have, some of you haven't. Okay, again, maybe a bit of duplication of what we're covering across both courses, but databases are important. If you don't have them set up properly in terms of developing the requirements for a system, your system's not going to function appropriately. So yes, there's an entire course devoted to the database side of things, but it's also relevant and extremely important in terms of how you model your domain from a systems analysis perspective and modelling the requirements for a system. So I've got a couple of videos on here in terms of how to think about identifying domain classes. You have a scenario, you need to think about who the user is, what interactions they have with the system. Well, how do we convert that in terms of thinking about how we actually develop and design the system, and what domain classes do we need to have? So identifying domain classes, looking at a couple of approaches in doing that, and also reading domain model class diagrams. So we need to understand and be able to interpret domain class diagrams. Again, these are UML models. One of those, again, a domain model class diagram, where we represent our domain classes. And for each of those domain classes, we specify some attributes for those domain classes, as well as providing relationships between those domain classes and how they interact with each other or how they link up in terms of how the system operates. Again, I've got a crossword for this week, so please select Chapter 4. And we're looking at the first half of domain modelling this week. First week back, we'll continue, and I'll do a bit of a recap on what we've covered today. So I guess, as I mentioned, we've already focused on modelling aspects and requirements for a system with use cases. Okay, looking at what the system does, looking at the verb-noun technique. Today and this week, you'll be looking at what a use case diagram is. You'll be looking at how to come up with use cases, how to identify internal, external, and temporal events, how to understand who your actors are, how to interpret what an actor does based on a given event and convert that into a use case to then determine in the verb-noun syntax what the system actually has to do. What is the functional aspect of that particular event that's triggered the system to do something? So that's what we've looked at last week. This week we're focusing on another concept, again to do with modelling requirements, which is data entities or domain classes. Now, in the RMO trade show system, which was mentioned in Chapter 1 throughout the textbook, just to give you some examples of domain classes, we have a supplier, a product, and a contact. These are all things. Okay, they're things that we need to store information about. If it's a thing and we don't need to store information about it, then we don't need to model it in our domain class. Okay, but if it's something that we need to remember information about, store information about, update information about, list information about, then it's generally something that we need to think about as a thing in the problem domain, and we have to create some sort of relationship or an entity or a class to represent and model that thing and what attributes are associated with that particular thing. So let's have a look at the video on domain classes. And that'll give you a perspective of a good way of identifying them.
When working to understand functional requirements for an information system, there are two key concepts that we've emphasized. One is use cases, talked about extensively in an earlier chapter. The other, domain classes. And use cases and domain classes interact together in order to define functional requirements. Now, problem domain classes are things that the users work with when accomplishing tasks. And these are things they work with that need to be remembered. Sometimes states change of these things. Sometimes new instances or new records of these things are apparent. These things in the problem domain are modeled as domain classes. And using UML as a modeling language, classes are a key concept. And problem domain classes will be the types of classes that represent these things that users work with. Some examples would be things like product, sales, shipper, customer, invoice, payments, things like that. They're typically the kinds of things you'd find when you were creating a data model in your database class. And sometimes they would be modeled as entity relationship diagrams. In this class, we'll mainly be looking at domain model class diagrams, which are pretty much the same as entity relationship diagrams for purpose of domain classes. These are some examples of types of things that might end up being domain classes when you're working on functional requirements. For example, it could be a tangible thing, an airplane, a book, a vehicle, a document, a worksheet. It might be role-played by people involved with the system, such as an employee or a customer, a doctor, a patient, an end user, a system administrator. Sometimes we find things as being organizational units, a division, a department, a section, a task force, a work group. Sometimes we're concerned about keeping track of information about certain devices. So you might have a sensor, a timer, an assembly line, a printer, a sorter. Sometimes we have sites or locations that are important to the business system. A warehouse, a branch office, a factory, a retail store, a desktop. And then sometimes we have incidents, events, or interactions that occur, something that happens that we want to remember, we want to store information about in the system, such as a flight of an airline or a service call, a contract, a purchase, an order, payment. Those are things that could be considered to be incidents or events. So there's lots of different types of things that you might want to identify for domain classes in your system.
So this is a really useful technique or a really useful slide for when you have to think about, when you have a particular scenario, which you may have in your assignment or you may have in your exam or whatever, really useful slide which gives you a perspective of how to think about what your things might be that you need to model in your problem domain. And look at these categories that have actually been mentioned. Tangible things, roles played, organisational units, devices, sites, locations, incidents, events or interactions. And there's a huge array of examples of the types of things that can actually have information stored about them or recorded about them, or things that may change for each of these things. Okay, so really useful to take this on board when having to think about the types of domain classes that you want to create for your particular scenario or for a system that you need to model.
So how do you go about identifying domain classes for your system? There are two main techniques that are commonly used. One is just generically named the brainstorming technique. And this is where you use a checklist, like the previous slide we looked at, to look at the usual types of things that you might find in the information system and try to identify domain classes from these types that might apply to your system. The second technique is called the noun technique. The noun technique is a little more systematic in that you try to identify all the nouns that come up when people talk about the system, when you interview people, when you read documentation, for example. And then you write all those nouns down and you try to determine if a noun is going to be a potential domain class. Sometimes it's an attribute of a domain class, and sometimes it's something that might be part of the system, but we don't really need to remember it. So those are the two techniques we'll talk about now briefly. With the brainstorming technique, you'll start out by identifying a user and then a set of use cases that that user is involved in. And then you brainstorm with that user to try to identify any of the things involved that they need to work with when they carry out that use case. For example, information that they might need to have captured by the system so that they can know about it and look it up later. And so this example of different types of things is a good way to systematically brainstorm. So you would ask the user, are there any tangible things? Are there any roles played? Are there any organizational units, etc.? So using this, you systematically can try to identify the types of things they work with and the types of things that they're going to need to remember. And then this, of course, becomes the list of domain classes. Repeating this with different users, with different types of users, will give you a pretty systematic way of identifying domain classes. The noun technique is a very popular technique because it's systematic and it's also fairly straightforward. And basically what you do is identify all the problem domain classes that might be part of the system by trying to first list all of the nouns that come up when you either discuss the system with end users or stakeholders, or when you read documentation about the system. So the noun technique can be done by referring to notes, by referring to documentation, without necessarily having to sit down with end users. Here's an example of some identified nouns for the RMO system that come up in documentation when you talk about use cases. You've got accounting, back order information, bank, catalog activity reports, catalog details. Now each one of these might be a potential domain class. On the other hand, they might not. Accounting, for example, well, we know who they are. There's really no need to store information about accounting. Accounting turns up as a name for an organizational unit that receives reports from our system. A back order might be something we need to remember. Is it a special type of order, or perhaps it's just the value of order status as an attribute? So we might want to research something like this a little bit more. Backorder information, well, this is probably an output that's produced from other information, so it's probably not going to be a domain class, although backorder itself might be a domain class. A bank is something that receives information from us. There's really only one of them, so there's really no need to store information about them. Catalog. Yeah, there's a catalog. We need to recall lots of different catalogs. There's different seasons, there's different years, and so we probably would need to include catalog as a domain class. Catalog activity reports, again, probably an output produced from other information that's sent out to some external agent of the system, so it's probably not a domain class. So as you can see, using the noun technique, you can end up with a very long list of nouns. And for each one of those nouns, you need to go through and figure out, well, what does it really mean? Is it an attribute of something else? Is it something that we don't really need to store? Or is it a potential domain class that might be important for our system? And then if it's a potential domain class, is it really the name for some synonym of something else, where different users or different documents have referred to the same basic concept using more than one term? So a lot of refinement is needed after thinking through all of the nouns before you can really come up with a good list of candidate domain classes.
Okay, so really useful, I think, to have a look at the techniques, the two different techniques available, the brainstorming technique versus the noun technique. Whichever technique is appropriate at a given point in time, whichever technique you find easier, whichever technique you find more valuable, or a combination of the two is what you can use to identify the things in the problem domain. Okay, you've got to have a problem domain that specifies an area that the users are going to use the system for or as part of or giving you a context. And as I said, the things are the products, sales, shippers, departments, whatever, that we need to store information about. We need to think about what the information is that we're storing, what attributes are being stored for that particular piece of information. And once we have established that and determined what things we have, we need to model them as either domain classes or data entities. Okay, very similar in terms of either a domain model class diagram or an entity relationship diagram. Throughout the course, we'll call them domain classes. In database, you may call them data entities. 6 of one, half a dozen of the other. So rather than going through these, I thought it was useful to show you that video. Because it does give you some interesting perspectives on how to think about the two particular approaches. The brainstorming, again, is a technique that uses that checklist and that slide that showed you the things and the different categories of things that you might want to identify classes with. The noun technique, again, if you have some documents, if you have some information that's listed, you can start with the noun technique. You can identify all the nouns, and then for each of those nouns, as you have, and you list them in a table, then you determine, is this something that we need to store information about? Are there multiple instances of this particular noun? Is it actually an attribute for another thing that we need to store the information about? Etc., etc. And then systematically, as he said, go through that list and determine whether it's something you need to store. If it is yes, is it the thing that we're concerned with, or is it an attribute that is related to another thing that we've listed? Okay, and determine and categorise whether it comes under not needed, needed, but it's an attribute, needed, yes, it's a particular domain class or it's a particular entity. Okay, and come up with, I guess, a list of what you think needs to be modelled to satisfy the requirements of the system that's going to be developed. So again, reiterating the brainstorming technique. And I've included in the slides the steps that you would take in terms of if you chose to use each of these techniques or one of these particular techniques. So we've got the brainstorming technique, the steps, and then the noun technique and the steps. This is the partial list of the nouns for RMO, and that was basically the same slide that was represented in the video where a whole bunch of nouns were identified, and then he systematically went through and decided and provided some notes or comments for each of those nouns to come up with, I guess, a preliminary form of what the classes / entities would be for this particular system being RMO. Some things you need to be wary about, and again I may be reiterating some of this information if you've done a database class or if you're currently doing a database class, but it's important to understand what each of these things actually means and what they actually represent. So when we talk about an attribute, it's basically a piece of information about each instance of the class. So if we have a student, what do you think a particular attribute might be for a particular student?
Student ID.
Student ID. Okay, or student name. Okay, a particular instance of that class might be Kathy is the name. Student ID might be, I still can't remember mine from way back when, but I'm not going to say it. And then your mail ID. So I was a student here many years ago, and I do have a student ID, and I still am a student here because I'm doing a PhD. But anyway, instance of that class, you need to think about a particular example. So customer has a first name, last name, phone number. Similarly, if we have a student, we have certain attributes associated with a particular student. We need to think about an identifier or a key. So one attribute that uniquely identifies an instance of that class. What would be, from a student's perspective or from UniSA's perspective, what is the attribute or the unique identifier that uniquely identifies students? Student ID. Okay, is there another one?
Email address.
Email address or email ID, the mail ID. Okay, so one of those. What about student name?
No, that's duplicate. Potential duplicate.
Well, we do have a number of students with the same names.
John Smith.
John Smith being an example. I don't know if we've got John Smith, but there are a number of students, even within the same course, that have the same name. So it's really important to be able to distinguish information in your classes. So therefore it's really important to have an identifier, or otherwise known as a key or a primary key, to be able to pick out that specific instance of that class. So can we find Kathy throughout this list of entire students? Okay, and how can we identify Kathy? What is that identifier? We can also have a compound attribute, two or more attributes combined into one structure to simplify the model, i.e. an address, rather than breaking it down into the individual components. Okay, so it depends on how you set it up and how you use those requirements or those components within the system. If you need to have individual components, they must be separate attributes. If it's not necessary to separate them, then you can combine certain attributes together. So again, here are some examples of a class or a type of thing. An object is a specific instance of that class. So all these customers have attributes: a customer ID, family name, last name, and 2 different phone numbers, and they all have specific attributes for those names. So we can see there that we have the attributes filled out for each customer, going this way, going down. And we have 3 specific customers listed in this particular scenario, where we have John Smith, Mary Jones and Bill Casper, with their own unique identifier and various phone numbers. Associations. One of the things I also mentioned, it's also important to have relationships or associations and understand those relationships between our particular classes. An association is the term used in UML, which is a naturally occurring relationship between those classes. So we may have an order, we may have an accounting department, we may have a red shirt, size 1632, 401. So Mr. Smith works in the accounting department. An order is placed by Mr. Smith. Mr. Smith has a red shirt and has jeans size 34 long. Oh, sorry, yeah, you're right. The order contains a red shirt and the jeans, not Mr. Smith. I was reading the wrong thing. So it's what actually goes here, where you need to come up with what sort of relationship is going on. So Mr. Smith is between these, and we're talking about what the order actually contains. So when you have an association or relationship, it's also important, and it's basically denoted by a line between two classes or two entities. There are different ways we can specify the association or the relationship, and there are different directions in which you can read those relationships, which we'll look at in a moment. Not only that, it's important to label that relationship. In some cases in the book, and in some cases that you see, whether it's online, sometimes they don't label the relationship. I think it's really important that you do put a value there, not so much a value, a term there to identify what the relationship is. Works for, belongs to, plays in, goes to, has, does, whatever. Multiplicity. So it's a term for the number of associations between classes. So we can have a one-to-many relationship between classes. We can have a one-to-one relationship between classes. We can have a many-to-many relationship between classes, or a zero-to-many. Many different associations. And again, you've probably looked at this stuff in databases as well. I'm assuming and hoping that you've covered it in databases. So we need to read them separately each way. For example, a customer places an order, or an order is placed by a customer. Okay, so it's a bi-directional thing, and you do read them separately in each way, and that's going to determine the multiplicity and how that occurs, whether it's a zero-to-many, a one-to-many, a one-to-one, etc., etc. When the minimum is 0, that means the association between those two classes is optional. It means we don't necessarily have to have an association between those two classes. If the minimum is at least 1, then the association is mandatory. So that has to exist, that relationship between those two classes. To give an example, Mr. Jones has placed no order yet, but there might be many placed over time. So this is a 0 or more relationship, and it's optional because he doesn't necessarily have to place an order. An order contains at least one item, but it could contain many items. So the multiplicity is 1 or more, and it is a mandatory relationship. So it's important to understand what the relationship is, if it's mandatory, if it's optional, and to also understand whether it's 0, 1 or many, and which direction that 0, 1 or many occurs in. So one of these types of diagrams that we can create to represent the relationships between our classes or our data entities, as noted in entity relationship diagrams, is to use an entity relationship diagram. So we can create different views, one being a domain model class diagram, one being an entity relationship diagram. These are not typically known as UML models, but they have been used for many years, are still used, and they are basically the traditional approach to modelling requirements. Okay, just to give an example, when I studied here, there was no UML, it was entity relationship diagrams. Serves a similar purpose. How do we represent things in a problem domain? How do we represent the attributes for those things? And how do we provide relationships between those things? Okay, and there's lots of tools and techniques out there to create entity relationship diagrams. If you're using Microsoft Visio or Microsoft Access, particularly a database software package, you generally can create in a visual form the relationships with your diagrams. Are you using any particular piece of software for your database course to create databases? Visual SQL Enterprise? Okay. SQL or SQL or Visual Studio or whatever. There's various different types of software out there to enable you to model systems and model databases. So what do they normally show you? Okay, here we have cardinality being showed to show you the relationship between the two entities. Okay, so we have a customer and an order, and they use something called the crow's feet notation when we look at entity relationship diagrams. There are different notations that can be used. The authors in this particular instance, and in this case, call it the crow's feet notation. The way you read this diagram and the way you read the relationship between these two entities is that an order must be placed by exactly one customer. So this represents 1. Order must be placed by exactly one customer. When we look at it the other way, we say a customer can place 0 or more orders. So it's kind of the opposite direction in terms of how you read it. So the line or the notation doesn't actually belong to the entity that it's touching up against, if that makes sense. This actually belongs to what the customer can do in terms of the order. So the customer can place 0 or more orders. The order must be placed by exactly one customer. Here's some examples of crow's feet notation for the various cardinalities. We've got exactly 1, 0 or more. 0 or 1, 1 or more. So basically the line is the 1, the 0 is the 0, and the chicken feet, if you want to call it chicken feet, gives you the more option, and you can combine those to give you the different types of cardinalities. So here's an example of an expanded entity relationship diagram with attributes. You'll see a version of this with the entity relationship diagram. In a few slides, you'll see the same version using the domain model class diagram approach. So here we can see some entities. We can see the names of the entities. We can see some attributes. And we can see the primary key that's been identified. And we can see that they have cardinality placed here. Okay? I'll skip over the semantic net one, for example, for this point in time. Here we have another example, an entity relationship diagram for a bank, where we have a customer with an account, with a branch, with a transaction. And you can see that the customer and the account are linked. We can see that an account and a branch are linked, and we can see that an account and a transaction are linked. So account has 1 or more transactions. Here's one example of how to read that. A transaction is part of one account, or belongs to one account. Let's now look at that in terms of how we represent it with a domain model class diagram. I'm not going to show the video. It's on the course website. Hopefully you've probably looked at it before coming to class. If not, you can do so after the class. But what it's basically giving you is some terminology and some definitions in terms of the domain model class diagram. Again, very similar to an entity relationship diagram in terms of how it's represented. But it's important to understand what it looks like and how we model particular classes for a specific domain. And you'll have to create one of these for your final assignment in your group assignment. So we have a class, we have a domain class, we have a class diagram, and then we have a domain model class diagram that only includes, it's basically a holistic view, an overall view of the classes for a particular domain that you are modeling. So here we have a domain class which has a name for the class. It has a specific set of attributes for that particular domain class. Now there's some notation that you need to be wary of. Okay, that's really important. The class name is always capitalized. Okay, when you create the class name. And with notations, we are picky. UML has a specific set of rules and the way they represent things, so you need to be specific and you need to adhere to these rules when you are creating these particular types of models. So capitalized for the class name. The attribute names, there's a couple of different notations that they use, but in this book and this scenario they call it the camelback notation. What that means is basically when the words run together, the first word is lowercase and the second word is capitalized. Okay, so if there's two words, you put them together, the first word's lowercase, the second word is uppercase. This only applies for the attributes when you have compound class names and attributes. similar example to what I just showed you with the entity relationship diagram, and you can see that they are very similar in terms of how they're represented, except now the cardinality is not shown using the crow's feet notation, it's shown using actual numbers and dots and asterisks. So we've got the names here, camelback notation, so lowercase and uppercase. If the name up here is two words put together, they both have a capital. Okay, so that's the difference when you're combining two names for the actual class versus two words for the attributes. Okay, there's a distinction there. So the diagram matches the semantic net shown previously, and we can see that a customer places 0 or more orders. An order is placed by exactly one customer. An order consists of one or more items. An order item is part of exactly one order. So what I've just read there is exactly what is under here, and I've just shown you how you actually read the relationships between those particular classes. What's the UML notation for multiplicity? You can see it's given right there, and how it's represented if you need to show it in your domain model class diagram. And you do need to show it. Okay, it's really important to show the multiplicity and how the domain classes are actually, I guess, engaging, or how the relationship exists between those particular domain classes. So this is the bank example again, which I showed you the entity relationship diagram version. This is the domain model class diagram version. Again, we can see the notation here and the cardinality. And what they have left out is the naming of the actual association or the relationship. Get into the habit of actually including a name in here. Okay? So that's just, I guess, an introduction to entity relationship diagrams, thinking about things in the problem domain. Two different techniques, the brainstorming technique versus the noun technique, a way of formulating a scenario and thinking about the domains that you need to model, looking at things, looking about attributes, then coming up with a visual representation in terms of an entity relationship diagram or a domain model class diagram to visually represent the associations between those domain models. And I'll leave it at that for today. Have a good break, work hard on your assignment, and we'll see you after the break. And if I could have that class list back, that'll be great. Thanks.